the answer. Here, I'll put it up for you. There you go. 1.34. Okay, next now. Yes, ready? Now, some circuit diagrams. So, there's 4 of these batteries, and each battery is 1.5. What's that? Are you going to drink that?
No.
Alright. I thought you were going to go like,
Drink Jeff.
It looked like it. Well, hang on. He was drinking 2 litres of milk in class last time.
No, he just drank the water.
But it's a legitimate liquid that you can
Oh,
drink.
the trill, but 2 litres? Yeah. Ah, okay. I understand. Okay.
It's only one I ate.
That's all you had today? No lunch? That's terrible. Why not?
Student budget. Hot noodles.
Hang on. That's like a €2 coffee, so it doesn't make sense. Maybe you're fasting. Religious holiday? That's what my Arabic students do. Yeah?
Wait.
When does Ramadan start? Soon, isn't it? No, it's after the
So maybe it's
July?
next month. Yeah.
July. Okay. When you're long gone.
You care?
Huh?
You care about the Ramadan?
You know Ramadan?
Yeah.
Oh, you know it. Good, yeah. So they can't eat during the day.
Yeah, I know.
That's like what you're doing.
And the sun's going out.
Yes. Yeah, the sun is nearly gone, yeah. Alright, so here we got 4 1.5 volt batteries. So in total here is 6 volts, okay? And basically we've got these resistors we need to add together. Alright, determine EMF. So what is it here? It's 6. Because there's no resistance in these batteries. So the first part is 6. Oh, so don't forget, I put those books on Moodle. Okay, so you can get them if you need to. Okay, determine the total resistance. So, we know the formulas, okay, so I won't write it down. So this one, what you do is 1 over 200 plus 1 over 50, and then we flip it, and you get 40. Okay, plus 40, plus 20, so total 100. Is that okay? Yeah? Now determine the current flowing through the 21 here. So we want to know what the current is. So we can use Ohm's law. V equals I or, because the I is the same everywhere. So you got, the I is, I'll stop talking. V equals I or. So you got 6 equals I times 100. So it'd just be 6 over 100. So that's 0.06 amps. Yeah. Okay, D.
Wait, why 100?
The total resistance. You see what I'm doing?
From total resistance. I was from that one resistance.
No, but see, that's what they asked for. What if you look here? Yeah, I'm picturing this as 6 volt battery, and then 100 resistor here. So the current going around, that is going to be exactly the same as the current here and here. Now it will not be the same as the current here or here because it splits. But for the 20, it will be. Because you can put all of these together as one. Okay. Now, where's my question gone? Right. Now, the last one is determine the potential difference across the 40 here. So what's the voltage here?
Sorry.
It's okay. The voltage, yeah. Now, this is where you need to use maybe your Kirchhoff rules. You know Kirchhoff rules? Now, can you try to mentally take a picture of this so we can redraw it? So 20. Let's go around this way. No. Just use your mind. No. Just try to remember the numbers. Just write these down, please. 40, 50, 220. 40, 50, 220. Now, don't draw. Just write the numbers down. I'll remember the picture. You just write the numbers down. 40, 50, 220. All right, let's draw that. Okay. First, 40. Then, 200. Then,
50.
and then,
20.
20, I thought, wasn't it? Oh, dude.
Oh,
40, 250, 20. 40, 250, 20. And then the battery here is a 6-volt battery. And which way is it going? It is going that way, to the left. Okay, so let's draw in our currents. So here we have I1. Well, we know what this one is. It's 0 point whatever. I1. Here, still I1. But then this is where it splits. So it becomes I2. And here is I3. Now, here's a little trick for you. If I1 is coming out of the battery, then that means I1 is going into the battery as well. So you can draw it backwards. You know that I1 must be here. So that means here must be I1 as well.
So I1 minus I2 minus I1.
Now, I'd like just for practice to write as the Kirchhoff rules. You remember the Kirchhoff rules? Yeah. So, which one are we looking for? We're looking for the voltage here. You know what? I don't think I'll use Kirchhoff rules. I think what I'll do is I'll just combine these together as one big resistor. If you add these together, it will be...
100.
No, that was everything. I think it was just 40.
Yeah.
Get a bit of lag.
I love it when it does that.
You swear I was doing like some serious gaming or something, wouldn't you? No, I changed my mind again. I am going to use the Kirchhoff rules. Okay, so... Oh no! What's happening? Oh! Oh, there we go. Sorry. So, well, I'll try and write the formulas down here. So the first one we'll use is the junction rule, and we'll use it here. This was an I3, wasn't it? So we have I1 minus I2 minus I3 equals 0. And then if you use the junction rule here, you'd get the same thing. So I won't even write that down. Right, now, we have 3 unknowns, so I need 3 equations, so I need to make 2 loops. So I'll do the outside loop and then the inside loop. So on the outside I have 6, starts here, and then minus 40 I1. And then if I go on the outside, it'd be minus, that was 50, wasn't it? I3 minus 20 I1 equals 0. Is that okay?
What about the 200?
Yeah, no, that's the inside loop. I'll do that next. So you have 6 minus 40 I1 minus 200 I2 minus 20 I1 equal 0. So I'll write these down again, but neatly. And I'm going to change it to X, Y, Z to make it a little easier to write. So you get x minus y minus z equals 0. This one here, that'd be minus 60x minus 50z equal minus 6. And then here, minus 60x minus 200y equal to minus 6.
So then we can assume that 50z and 200y are the same.
They have to be. Because if you subtract the two equations. Okay. Now, this, I won't solve it for you, I'll use derive to solve it. I think I'll close Firefox because that surprisingly uses a lot of, it's kind of silly, uses a lot of processing power, and I don't need my Office program anymore. Alright, so good old derive here. Okay, close those. So, before I solve it, let me show you how to solve it. What you do is you have to pick something that's in all three of them. So which letter is in all three of them? There's actually only one. Yeah, it's only x. So you need to make this multiplied by 60. So you have 60, 60, and 60 here. And then you put these two together, and then there's no x. There's just y and z. And you put these two together, and now there's no x. There's just y and z. So then what you have here is just y and z. And then it's just a normal problem then. So did you write these equations down? And we'll get derive to solve it. Okay, so the first one is x minus y minus z equals 0.
Minus 16x.
Minus 16x.
Minus 50x. 15x.
You meant 60, didn't you?
60.
Yes. Minus
50x. Z, sorry.
yes.
Equal minus 6.
Okay, and then the next one?
Minus 60x.
Yep.
Minus 200y.
Yep.
Equal minus 6.
Okay. Solve system. Three equations. 1, 2, 3, and don't like the 0 and 0 here. Did you read them out right?
Yes.
Oh no, sorry, my bad. I typed in x minus y minus x. You know, not your fault, Curdy. My fault. Right, try that again. Solve system tray. There we go. So which one do we want? We want through the 40, which is the I1, which is 3 over 50, which is what we got previously, I think. Anyways, it doesn't matter. We got 3 over 50. So we can use Ohm's law now. V equals I, or I is 3 over 50 and the or is 40. So the V is going to be 3 divided by 50 times 40. 2.4 volts. Yeah? Is that okay?
Yeah. This is point to
Huh? 2.4. Scroll up? Yeah. I got my answer from derive. 3 over 50 was the I1. Yeah? Sorry. Do you need the diagram? This isn't...
I just tried to calculate.
Oh, okay.
Take a long time.
It does, doesn't it? Yes, that's what it worked out to be. Yes. Okay. So stop that next one.